So here is another question. It is given how many grams of ice at minus 14 degrees Celsius are needed to cool down 200 grams of water from 25 degrees Celsius to 10 degrees Celsius. Some information is given. Specific heat of ice is 0.5 calorie per gram per degree Celsius. Specific heat of water is 1 calorie per gram per degree Celsius, and latent heat of fusion is 80 calorie per gram. Okay, so now let us try to understand what this question means. So we have, let's say, ice. Let's say m grams of ice are there. Okay, m grams of ice at minus 14 degree Celsius. Now we have, let's say, a container of water which is at an initial temperature of 25 degree Celsius. Okay, this is water. 200 grams of water. Now when this ice is put into this container, the temperature of this water from 25 degrees Celsius drops down to 10 degree Celsius. So here in this situation, this 200 gram of water at an initial temperature of 25 degrees Celsius is the hot body because it is at a higher temperature, and m grams of ice at minus 14 degrees Celsius is the cold body. Okay, so when ice is mixed with water, the temperature of this ice at minus 14 degrees Celsius, it increases, and the temperature of 25 degrees Celsius of 200 grams of water, it decreases. So finally they arrive at an equilibrium temperature of 10 degree Celsius. Now we have to determine how many grams, how many mass of ice at minus 14 degrees Celsius will be required to arrive at this equilibrium temperature. So basically it is based on the concept of heat loss and heat gain. So what will be the the sequence of events of this whole transition process, how it will take place, that we'll see. So first, here this is not a strict order, I'm just noting down the event. So let's say number one, first the 200 grams of water at 25 degrees Celsius, it drops down in temperature, decreases in temperature to how much? 10 degree Celsius. So a difference in temperature of how much? 15 degree Celsius. 15 degrees Celsius drop. Now this will take place through the concept of specific heat of water, CW, and this 200 grams of water, it will lose heat. There will be heat loss. Only then the temperature will decrease. So the heat loss in this 200 grams of water, that is equal to the mass of water. So the heat loss in the 200 gram of water at 25 degrees Celsius initial temperature, when it drops down to temperature of 10 degrees Celsius, that is equal to the mass of water, specific heat of water, and change in temperature. So the mass of water 200 grams, specific heat of water 1 calorie per gram per degree Celsius, and change in temperature of 25 minus 10, that is equal to 15 degrees Celsius. So it is equal to 3000 calorie. This is the loss of heat, the net loss of heat. Now next, we have the m grams of ice at an initial temperature of 14 degrees Celsius. It will gain heat, okay, when it comes in contact with higher temperature water, 25 degrees Celsius temperature water. So obviously it will undergo transition, so it will gain heat. So the transition will take place as m gram of ice at minus 14 degrees Celsius. It increases in temperature to m grams of ice at 0 degree Celsius. Okay, 0 degree Celsius. This is the first sub-bit, okay, here of the second transition. Then the m grams of ice at 0 degrees Celsius will undergo transition to m grams of water, m grams of water at 0 degree Celsius. Okay, m grams of water at 0 degree Celsius. And then we have the m grams of water at 0 degrees Celsius will increase to m grams of water at the equilibrium, the final equilibrium temperature, that is 10 degree Celsius. This is the the sequence of events, how it will take place. Now this transition from ice at minus 14 degrees Celsius to ice at 0 degrees Celsius, it will involve specific heat of ice. Okay, then this transition from m grams of ice at 0 degrees Celsius to m grams of water at 0 degrees Celsius, that will involve latent heat of fusion. Why? Because temperature is constant but only the phase is changing. So this latent heat or hidden heat is utilized in transition of phase from solid to liquid. And then again, this m gram of water at 0 degrees Celsius to be converted into m gram of water at 10 degrees Celsius, it will again involve specific heat of water. Okay, specific heat of water. So this transition calculation, this heat gain which leads to temperature increase, heat gain 1 here is equal to m C ice delta T, and here the same mass m is involved. So it is equal to m, specific heat of ice is equal to 0.5 into delta T is equal to how much? The change in temperature 14 degrees Celsius, from minus 14 to 0, a change of 14 degree Celsius. So it is equal to 7 m. This is heat gain in the first sub-bit of the transition phase. Okay, let me use this. subbit 1. Then in the second subphase we have latent heat. So this gain, that is equal to the mass of ice into latent heat of fusion. So which is equal to m into latent heat of fusion, that is given 80 calorie per gram. So it is equal to 80 m. And then we have specific heat of water that will be involved to increase the temperature of m gram of water at 0 degrees Celsius to m gram of water at 10 degrees Celsius. So this gain in the third subphase, that is equal to m C water delta T. Okay, mass, specific heat of water, change in temperature, that is equal to m into specific heat of water, that is equal to 1 calorie per gram per degree Celsius, into delta T, change in temperature of 10 degrees Celsius. So it is equal to 10 m. So the total heat gain is equal to gain in the first subphase, gain in the second subphase, second step, and gain in the third step. That is equal to 7m plus 80m plus 10m. That is equal to 97m. Now, according to the principle of calorimetry, net heat gain, that is equal to net heat loss. Now the loss of heat in loss of heat in 200 gram of water at 25 degrees Celsius to 10 degrees Celsius, that is equal to the gain in heat of ice at minus 14 degrees Celsius to 10 degrees Celsius. Okay, so that implies 97m is equal to 3000 calorie. What is 3000 calorie? That is the heat lost by water at 25 degrees Celsius to undergo change to 10 degrees Celsius, and 97m is the heat gained by ice to change from minus 14 degrees Celsius to 10 degrees Celsius. That implies m, which is the mass of ice which will be required to to aid in this transition, that is equal to 3000 by 97. So it is coming 30.927 grams, or we can round it off to 31 grams. This is the mass of ice that will be required to add to 200 grams of water initially at 25 degrees Celsius to change the temperature, to drop the temperature to 10 degrees Celsius. Okay, so again I am highlighting here, this gain, heat gain, is ice undergoing transition from minus 14 degrees Celsius to 10 degrees Celsius, and this loss is in water to undergo transition from 25 degrees Celsius to 10 degrees Celsius. In both the cases we have 10 degrees Celsius, which is the final equilibrium temperature, and we have just equated the heat gain and heat loss to determine the mass of ice required. Mass of ice required at minus 14 degrees Celsius to help in this transition. Okay, and this is the result. In decimal form, this is rounded off. Okay.